Today's problem was submitted by a viewer, and it comes from the STEP examination. And it says, given that pi squared is less than 10, well, it is, prove that 1 over log base 2 of pi plus 1 over log base 5 of pi is greater than 2. And it looks like there's a second question, perhaps. It says, given that log base 2 of pi over e is greater than a fifth, and that e squared is less than 8, prove that the natural log of pi is greater than 17 over 15. Okay, well, let's look at the first part. Pi squared is less than 10, so that's just a fact. We want to show that 1 over log base 2 of pi plus 1 over log base 5 of pi is greater than 2. So first, a couple things come to mind. The first is I'm going to rewrite these in terms of, I'll have this is log pi divided by log 5, something similar there. And then I'll have something written with a common denominator, and maybe I can manipulate things and use this somewhere. The other thing I want to keep in mind is there's something that it looks like a constrained, not either a constrained optimization or something along the lines of the fact that arithmetic means, geometric means, and harmonic means have inequalities that are satisfied. So like the arithmetic mean is greater than the geometric and harmonic mean. If I take a square root of this, it's like the left-hand side is like the geometric mean of pi with itself. This looks like something to do with a harmonic mean. Harmonic average, but I'm not really sure where that's all going to lead to. So I don't see exactly the entire path to take here to get this, but I'm going to start by manipulating this and writing it like this: log of 2 divided by log of pi plus log of 5 divided by log of pi so this is equivalent. If I prove this, it's equivalent. This is log of 2 plus log of 5 divided by log of pi. Again, these things are equivalent. Log of 10 divided by log of pi. And that's again equivalent. And then I've got log of 10 greater than. Okay, well now I see where things are going. The proof here is literally just starting with the equation where the inequality given and proceeding upward like that. Every single one of these, this inequality is equivalent to that one, and this inequality is equivalent to that one. I've never multiplied by 0. I've never anything like that. So all the steps can be undone perfectly well. And there is the sequence of steps from the starting inequality up to the one that we want. So that's perfectly fine. Okay, I thought there would be something else here, more than just manipulating the expression using laws of logarithms and so on. Of course, it did pop out to me right away that 2 times 5 is equal to 10, but I just didn't see immediately how that was going to come up. So we didn't need to use all that arithmetic average, geometric average stuff at all. Although maybe that's another way of doing it. Okay, the second part of the question is given log base 2 of pi over e is greater than 1 over 5, and e squared is less than 8. Prove that the natural log of pi is greater than 17 over 5. 17 over 15. Okay. I'm not sure where the constants 17 and 15 are coming from. I don't really see simple combinations of any of the numbers given that might lead to that. Okay. Well, the first equation says log of pi minus log of e divided by log of 2 is greater than 1 over 5. That's 1. So maybe we're getting something already. So log of pi minus 1 is greater than the log of 2 divided by 5. Log of pi is greater than log of 2 over 5 plus 1. E squared is less than 8. How do I use that here? And where's the 15 coming from? Oh, okay, hold on. So, I mean, I'm using a little bit of the fact of what we're trying to prove here. I'm just going to multiply the right-hand side by 3 over 3. Yeah, okay. So I've just multiplied both the numerator and denominator by 3. That gives us the 15 in the denominator. And then here, I have log of 2 to the 3, which is 8, using some, just a simple law of logarithms. Now I see where things are going. Okay, so I'm using the other inequality now, that e squared is less than 8. I can replace the 8 with an e squared, and the right-hand side gets smaller, so the inequality is preserved, and the log of e squared is 2. So log of e squared is 2. This becomes 17 over 15, and that's what we wanted. Cool. Okay. Again, it just came down to manipulating laws of logarithms and there were a few steps here where where a little bit of foresight allowed me to manipulate the equations or inequality in the way that I wanted. So writing log of pi over e as log pi minus log e, that becomes a 1. And then we've kind of gotten rid of some strange looking term we didn't want at all. And this was kind of going from here to here was kind of a stab in the dark. But as soon as I realized multiplying by 3 over 3, it gives us the denominator we want, 15. As soon as I saw this, before even writing it down, I kind of understood where the other inequality that was given, e squared less than 8, I saw where we were going to be able to use that. We can replace 8 with e squared and the inequality doesn't change. Yeah, okay. So again, a nice little problem. No individual concept here is very difficult, but it's really just about, I guess, the practice and experience of sort of knowing where individual steps might lead you helps you decide what kind of steps you want to take next. So thanks for the submission, and thanks for watching.